We're going to begin 4.1, or Chapter 4, talking about quadratic functions. We have many new vocabulary words to go along with this. We discussed this a little bit in Math 1, but here we are going to actually go into much greater detail about quadratics. Some basic key things here is that a quadratic is also called a parabola. If you graph a quadratic function, you'll get a parabola, and that is essentially a curve. It's not a V, it's kind of more like a U than anything else, and that can open up or down. The standard form of a quadratic is when it's solved for y, and you have the powers in order. X squared, x to the 1, and this one is x to the 0, but we don't have to write that. Some key terms that go along with a quadratic is that when you have a curve, you'll have a lowest point, and this will be called a min, or a minimum. It's also called the vertex. If it opens downward, you have a maximum vertex. These are coordinates, and we'll learn how to get those, but they are an xy coordinate that we will describe, and I'll show you how to get that later. When you have it in standard form, your y-intercept is your c. It's the constant. If you graphed a parabola, from the graph you can see where the y-intercept is, and you will also have x-intercepts. Some qualities about the equation or the function are that when it's in standard form, if the a value is positive, the graph will open upward, and the minimum, or the vertex, will be called the minimum because it's the lowest point. If a is negative, then it will open downward, and the vertex will then be called a maximum because it's the highest point. When you graph a parabola, it mirrors, or it is symmetrical, and that line that goes right through the middle of it is called a line of symmetry, and I will usually refer to that as LOS. This equation will give you the line of symmetry. It's of the form x equals something. That's why we have vertical lines. The b and the a come from the coefficients in your initial equation. When you know the line of symmetry, you will know the x value of the vertex. When you want to find the coordinate of the vertex, once you find your line of symmetry, you can plug that x value into your initial function and find y. They work together that way. And again, c is your y-intercept. Let's try this question. Does it open up or down? Well, based on what we just discussed, if the a, and let's write this down, the a in this case is 3, the b is negative 18, the c is 25. Does it open up or down? Well, the c is positive, so it will open up. If that's the case, we will have a vertex that's a minimum, just to keep that in mind. What is the equation for the line of symmetry? Well, we know the equation is y equals negative b over 2a. So if we plug in our b value, we said it's negative 18. Our a value is 3. That'll give us 18 over 6, which is 3. And again, I did something wrong here. I'm not sure if you noticed, but I did not quite finish my x. It is, the line of symmetry is x equals, not y equals. Therefore, we have a vertical line at x equals 3. And that will cut our graph in half. Once you know that, you can find the vertex. Because remember, a vertex is a coordinate whose x value is the line of symmetry. So we will take that x value and plug it into our function. It says to take 3 times x squared minus 18 times x. And we work that through and we get 3 times 9 minus 54, which is 18 times 3, plus 25. So we have 27, which is 9 times 3, minus 54, plus 25. That equals -2. That is the y value of our vertex. And again, the y-intercept is the constant, 25. We're going to graph this. So we have to remember these important things. We have the vertex, the y-intercept, and the line of symmetry. So the vertex was the coordinate 3, -2, and these units go by 2's for the y-axis, so 3, -2 would be there. We have a y-intercept of 25. Oops, sorry about that. 25 to be here. I believe that's there. 20, 22, 24, 26. It might be here, actually. That's 25. That goes by 2's, right? Okay, we have a line of symmetry that cuts this in half. Okay, which means that our y-intercept will be reflected across that mirror because it has to be symmetrical. So if it takes 3 units to get to the mirror one way, I can go 3 minutes the other way and mirror it. And that gives me a parabola. Now it's not a V, it does bend. The best I can graph it. Alright, so let's take a quick look at my calculator and put it in. Here's my equation. I plug it in. If we graph it, that's what it looks like. And I'm going to stop right there. Thank you very much.